A glance in the direction of anything essential to human life will almost always reveal a long and fascinating history, and blood is no exception. These days, we take our understanding of blood for granted, but civilization didn't always deserve to boast about its blood-based knowledge, although the old physicians did anyway. With relatively new knowledge, scientists began discovering more and more about this surprisingly complex substance. And this research and the ability to analyze blood came the discovery of golden blood. But what exactly is this mysterious golden blood? What makes it so special? And most importantly, why is it so dangerous? To answer these questions, it's probably helpful to step back in time to about 2,000 years ago. These days, even those who know nothing still know it's best to keep blood inside your body. But that wasn't always the most widely accepted recommendation. The ancient Greeks are partially to blame for the strange understanding of blood. They put forward a theory which stated that blood was one of 4 humors in the human body. Humors were bodily fluids which were essential to life. There were, according to the Greeks, 4 of these humors in our bodies: black bile, yellow bile, phlegm, and of course, blood. There were also 2 blood systems in our body: purple, nutritive blood made in the liver for digested food, which was heated by the heart and pumped through the rest of our body, and scarlet, vivifying blood, which was made from air in the lungs and traveled through the arteries. These humors, including all blood, were also associated with the fundamental elements: earth, water, fire, and air, as well as the 4 seasons. And this is where the problem comes in. They believed the balance between these humors was crucial to health, but that corresponding seasons sometimes caused an excess of one specific humor in the body. Blood, for example, was associated with spring, meaning you might find you have too much blood in your body in the springtime, which causes disease. We know now that this is nonsense, but at the time, they believed it was essential to restore balance, either by promoting an increased production of the other 3 humors, or by removing the excess of the one being overproduced. The most obvious way to remove excess blood is to cut open a vein. At the time, this was known as breathing a vein, but this practice continued for far longer than you'd expect. In the 13th century, the Persian scholar Ibn Nafi had a breakthrough when he discovered the pulmonary circulation of blood between the heart and lungs. Unfortunately, Europe took no notice of this amazing discovery. Jump to Shakespeare's time, and bloodletting, as it was then known, was still all the rage. It was being used to treat just about everything, and in the 1800s, leeches became a pretty popular way of letting blood. Doctors probably just turned a blind eye to all the diseases being spread by their precious leeches. But all this doesn't mean there weren't genuine scientific breakthroughs at the time. In fact, the building blocks for our current understanding of blood were being laid. Blood transfusions between animals and humans were being attempted as far back as the 1400s. There was no success until 1665, when British physician Richard Lower performed the world's first successful blood transfusion. This transfusion was done between 2 dogs, but the success sparked a renewed interest in the practice, which scientists once again tried to transfuse blood from animals to humans. This, once again, led to plenty of human deaths, and the practice was outlawed. But it did lead to a crucial discovery. A man named Leonard Landoy noticed something interesting. When human and animal blood was mixed together in a test tube, it clumped together. In 1818, the British obstetrician James Blundell performed the first successful human-to-human blood transfusion, saving a patient from postpartum hemorrhage. But even with the proven technique, patients still continued to die, baffling doctors everywhere. It was the Austrian physician Karl Landsteiner who finally made a breakthrough by building on the work of Landoy. Landsteiner began mixing blood samples from different people together in test tubes, and he proved that some human blood samples clump when mixed together, the same way human and animal blood mixtures do. In 1909, he used this discovery to finally classify different blood groups into A, B, C types. Later, he renamed the C type as O, and his students helped in the discovery of the AB type. He then went on to discover the rhesus factor, which allowed the classification of blood into a further 8 main groups. In 1930, he received the Nobel Prize for his incredible efforts. It was his discoveries that made blood transfusions possible, saving countless lives, especially during the First World War, when blood transfusions were performed on the battlefield for the first time in history. But it's also his discoveries that bring us to the modern understanding of blood. We've already hinted that blood types are more complex than A, B, O, and positive or negative. The Rh system discovered by Landsteiner is another system with multiple classifications, as well as positive and negative. But what does it all mean? The important factor in blood types is something called an antigen. Antigens are proteins on the surface of red blood cells, and they're pretty important for a number of essential functions. But for the purpose of this discussion, we'll focus on their role in recognizing foreign cells. If your immune system recognizes an antigen on a blood cell, it'll leave it to carry on its journey through your bloodstream. However, if a red blood cell has an antigen on it which isn't recognized by your immune system, it'll initiate defensive systems in your body to destroy the cell. This is a really big problem if you're receiving a blood transfusion, because foreign antigens lead to shock, illness, and often death. This is why Landsteiner's discovery is so important. Without his breakthrough, we still wouldn't know how to safely perform blood transfusions. But the ABO and Rh systems are just two ways of sorting blood into groups. There are actually hundreds of different antigens spread across 36 blood group systems, meaning there are, in reality, millions of different blood types. Luckily, not all of this needs to be considered during a transfusion. Scientists know now that not all antigens are equally likely to be attacked by your immune systems, so some are safe for transfusion, even if they're foreign to their new body. This means not all of the 36 known blood group systems need to be looked at when a transfusion is needed. The ABO system is well known to be important, with O working as a universal donor because they lack A or B antigens, meaning normal immune systems don't have any way of recognizing them as foreign. But there are other important blood groups too, such as the MNS, Kell, KID, and Duffy systems. This is where golden blood comes in. It's one of the rarest blood types on Earth. Golden blood is defined by the Rh system, which Landsteiner discovered. The Rh system refers to 61 potential proteins, which we might have. Everyone has one of these 61 proteins, except for people with golden blood. Golden blood is a nickname for those with Rh null blood, and it is extremely rare. It was only in 1961 that a living human with this blood type was discovered. Previously, scientists assumed that embryos with this blood type would die in utero. So the discovery of a living adult woman with this blood type was a pretty major scientific moment. Since her appearance in 1961, only 43 other people are known to have lived with this blood type. When we said it was rare, we meant it. But it's also a pretty astonishing feat for those 43 people to have lived with this blood type, because it's pretty risky. Because people in this rare Rh null blood type lack any Rh antigens, a blood transfusion from someone with any of the 61 possible Rh antigens could be fatal. And everyone on Earth except Rh null has an Rh antigen. This means that people with golden blood are encouraged to donate blood to themselves, which means giving blood to be frozen just in case they need it in the future. So we now know why having this blood type is so incredibly dangerous. But why is this rare blood type known as golden blood? Like the O blood type, which is known as a universal donor because it lacks an A or B antigen, Rh null blood lacks any Rh antigen. This means they can give blood to anyone, no matter what Rh type they are, because there is no Rh antigen that your body can recognize as foreign. This not only means that golden-blooded people can give blood to anyone, it also means that their blood may be crucial in saving the life of someone with a rare Rh blood type who can't accept blood from anyone else. The Rh null blood is, therefore, life-saving and worth its weight in gold, at least in a figurative sense. The world took so long to discover the complexities of our blood, despite how essential it is. Now, we know so much that we're beginning to discover blood types as rare as Rh null, even though scientists thought it was impossible to survive it. We may still discover more types that we don't know about, but we do know that even though it's dangerous to live with this incredibly rare blood type, their golden blood is incredibly valuable as a lifeline, which could potentially save someone who can't be saved by anyone else. And this is all thanks to a few scientists who thought outside the box after thousands of years to get us to where we are today.